Hey guys, in this video we are going to talk about how to draw the Lewis structure of this compound here. So I've done a complete video on what Lewis structure. So yeah, I'm just going to show you how to draw the Lewis structure. But if you want to actually understand what is called Lewis structure, valence electron, octet electron, bonding electron, non-bonding electrons, and stuff like that, I will link a complete video on chemical bonding where I start from scratch to the end. You get. I will leave the link at the description below, but for now let's focus on this one here. So how do you draw the Lewis structure of what? N2O4 dinitrogen tetraoxide. You get, that is name. Is what covalent compound. Now what is a covalent compound? Covalent compound is a compound between two non-metals. So whenever you see two non-metals in a compound, is what covalent compound. You get. So now the first you want to look when you want to draw. Step number 1 is to calculate the valence electron, which is V valence electron. Do you get that? Of the molecule. So now what is valence electron? The valence electron of any element is a group number or the atom's electron. You get. So for nitrogen belongs to group 5, or the atom's electron is 5. So the valence electron is going to be 5. So we're going to do 5 times 2, right? Plus. Now for oxygen, the valence electron is 6. So here we have 6 times 4. You get. 2 is the numbers of nitrogen in the compound. 4 is the numbers of oxygen in the compound. So 5 times 2, here we have 10 plus 6 times 4. We have 24 equals to 34 valence electron. So this first thing you want to do when drawing Lewis structure of any compound. So you have to calculate the total valence electron. Step number 2 is to draw the scalency. Now what do you understand by scalency? In the sense that what you want to do is that the elements that come least will be at the central points, while the one that is having the highest electronegative power is going to come second. Now what do I mean? Going to be side atom. What do I mean? Here we have 2 nitrogen and 4 oxygen. So how are you going to do that? 2 nitrogen will be at the central atom. That is 2 nitrogen connect together. Remember we have 4 oxygen. So one will take 2 oxygen, one will take 2 oxygen. Do you get that? One will take 2 oxygen, one will take 2 oxygen. Here we now have this one here. This is called the scalency. You get. So remember, after drawing the scalency, I want to have each of them connect to each other with a single bond. Now one thing I want you to understand is that a single bond contains 2 bonding electron. You get. So out of the 34 valence electron now, I have how many bonds here? 1, 2, 3, 4, 5. I have 5 bonds. One bond contains how many electron? 2 electrons. Meaning that out of 35 electrons, I've used 10 electrons, because 2 electrons here, 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 making it 10. You get. So I now have my remaining electron. If I should subtract 10 from this 34 valence electron, I'm going to have 24. So I'm going to have 24 as my remaining electron. Do you get that? The next thing I want to do is to make sure all the atoms have their octets. Start from from the side of atom. Remember, when you talk about octet, that is the atom or the element must have the 8 electrons. Either when you sum the bonding electron or non-bonding electron. Do you get that? So if you focus on this one here, oxygen already have 1 bond, right? And 1 bond contains many electrons? 2 electrons. So if something needs 8 electrons and is already having 2 electrons, how many electrons does it need again to complete the 8? It's going to be 6. So that is going to have 6 electrons. It's going to have 6 electrons. It's going to have 6 electrons. It's going to have 6 electrons. Do you get that? If everything has 6 electrons, 6, 6, 6, 6, if you sum everything together, that is going to be 24 valence electrons. That is remaining. So you are going to put it here. I must put them in pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Right? 24. You get. So that is, I've exhausted my O34 valence electron. You get that? So the next thing you want to do here is to make sure that all the atoms in the molecule have their own octets. Now, if you look at it very well, oxygens that already have what their octet or electron. But if you look at this nitrogen already have 3 bonds. Nitrogen already have 3 bonds. This guy is not having the octet because 3 bonds only contain what 6 electrons, but it needs what 8 electrons. Do you get that? So how are you going to make this one to be what to be 8? You are not to include additional electron here like this because why? You have already exhausted your electron. You get? So this is where the next will come into play here. If the central atom do not have the octet electron, what are you going to do here? Move a sufficient non-bonding electron from the side atom to the central atom to form a multiple bond until the central atom have what the octet. It's very easy. Now remember here we have what non-bonding electron. This one is called non-bonding electron or non-bonding pairs. You get? So if you should move this one to this point here to form a single bond, to form what a double bond here, this will now have what the octet. Likewise, if you move some here, this will now have what octet. So in the sense that, so this is what I'm going to get here. So if you should move some here, this is what I'm going to get a double bond here. So remember, you have moved some. How many non-bonding pairs? You now have 2 lone pair, which is this guy and this guy. You get? Remember, this one here. You will have this one here. The same thing with this other one here. Now if you should move some here, you now form what a double bond. Then if you move some here, 1, 2, 3, 4, 5, 6. You get? So this is now what the Lewis structure for what this compound. You get? So if you checkmate it very well, all atoms are now having their octet electron. You get? This is now what the correct Lewis structure. Hope you understand. So go down, go to the description below, or you see a link here like this, a video here. Click on the link there and watch a full or a complete video on what Lewis structure. Thanks for watching.